Just gotta take it one day at a time, and Lord willing, we're gonna end up on top. Okay, everyone, let's get going with number 7. Hey, let's make a chart. Okay, we have two events, A and B. So we get A, we have A doesn't happen. I don't know what I'm typing there. We have, this is going to be total probability, okay? This right here is B. It's going to be B does not happen. And then total probability is at the end. Of course, 1 is the magic number. Everything needs to add up to 1 somehow. All right. We have the probability that A will occur is 50%, 0.5. We have the probability that B will occur is 0.6. 0.6. We can now fill in the chart, or the sides of the chart. Since they both need to add up to 1 on this left side, they need to add up to 1 on the bottom side. We know that the probability that B does not happen is 0.4. The probability that A does not happen is 0.5. Okay, we need one more piece of information, and there it is. The probability that both A and B will occur is 0.1. So I'm going to put a 0.1 here, and that should help me fill out the rest of the chart. Okay, so let's see, 0.1 plus 0.4 is going to give me 0.5. 0.1 plus 0.5 is going to give me 0.6. Let's see, this needs to be, oh, that's got to be 0. Okay. That's got to be 0. So notice what happens here. Either A happens, B happens, they both happen, but it's never going to happen where neither happens. Did I say that correctly?
Yes.
Yeah. A and B or both always happen. So let's see, for part 7, the conditional probability A given B. Oh, before we do that, we can also just find out whether these two events are independent by using some multiplication. They're not independent, right? Awesome. If you guys can see they're not independent right now, you're doing great. Good job.
They're independent because 0.6 and 0.5 don't add up to 0.1.
Don't multiply to make 0.1.
Yeah,
that would be Christopher. It's because 0.4 and 0.5 is not multiplied, right? Wait, what direction multiplies?
Any, 0.6 times 0.5 should give me this box.
If, let's say, A and B was 0.29 something, then they're independent. Because 0.29 is 0.3.
They'd be close to independent.
Okay.
I wouldn't say they're actually independent, but they are very close. In fact, they're probably close enough for you to treat them like they were independent.
Okay.
But the fact
Yeah,
is they're
that's
not
enough.
independent.
Wait, I don't get what I want to ask, the probability the conditional probability of A given B is.
Okay, so what that means is, that is a question, right? The probability of A given B. What that says is, you know that B is true already. Okay. If you know that B is true already, what's the probability that A is going to happen also? Okay. So we can go back to our formula. Probability of A and B divided by the probability of B. Okay. And then now you can read that. Where's A and B? It's 0.1, right? Divided by probability of B, it's 0.6. That gives you 1667.
Mr. Ferreira?
Mm-hmm.
So anytime it says conditional, it's going to be the one with the line in the middle?
Yep.
What?
This also tells me that they're not independent because probability of A given B is not the same thing as the probability of A. Okay. Number 8.
The probability of A is
Can you repeat that again?
Yeah, if the probability of A given B is equal to the probability of A, that's another sign of independence.
Correct. Yeah.
Ocho. We can conclude that they are they independent? No, not independent. So
They are disjoint.
we can conclude A.
You don't know.
Okay, they're not independent. Okay, there's two clues here. Clues. Okay, probability of A and B is not equal to probability of A times the probability of B. That's one clue. And the other clue, probability of A given B is not equal to the probability of A. Those are the two things that clue you into the fact that these are not independent. Any one of those would kill independence. One. B. Are they disjoint? Not disjoint, right? Okay. Disjoint means the probability of A and B equals 0.
I thought you said that if they're not independent, then they're disjoint.
No,
That's not always the case.
that's not always the case.
Okay.
But isn't A and B 0.1?
Yeah,
That's not
exactly. It has to be 0 for them to be disjoint.
Okay.
C. A or B always occurs.
Yeah.
Yes, this is true.
Because A complement, B complement are 0?
Yes, since the probability of A complement and B complement equals 0. So in other words, both events not happening at the same time never happens. That's hard to say. That's a mouthful.
So let's say we're at 0, then they wouldn't always occur.
Yeah. It's not possible that A doesn't occur and B doesn't occur. Okay, we have found the correct answer, but we're going to continue on anyways. D, A and B are complementary. Complementary means they add up to 1, right?
Are they?
No. Complementary.
Oh, because 0.6 and 0.5?
Yeah.
Wait, can you explain like
Complementary, yeah. There are two things for complementary. Okay. Not complementary. Number one, the probability of A and B has to equal 1. No. A or B equals 1. 2, the probability of A plus the probability of B has to equal 1. Yeah, that's it. Okay. All right, that takes us to 9. Just want to pause and make sure everyone's okay with number 8.
I have a question.
Yeah.
So whenever they say the probability of A or B, the formula for that is PA plus PB minus PA and B.
Yes.
Always.
Always.
That one?
That'll always work. Question?
Yeah,
That Julia?
how are, if two events are disjoint, how are they not
How are they not independent?
like right past?
Yeah, well, yeah, I did write that, but let's see. Independent means the probability of A given B is equal to probability of A, right? Probability of A, right? Okay. Well, if they're independent, the probability of A and B is equal to 0, right? Or if disjoint, the probability of A and B is equal to 0. Okay. And so what that means is that we take this formula, and that's going to be, sorry, independence, right? That's going to be equal to the probability of A and B divided by the probability of B, right? That's going to be 0 if they're disjoint, which is not going to be equal to the probability of A. Therefore, not independent. Outcomes are dependent. Okay. Okay, number 9. Experience shows that a certain lie detector will show a positive reading 10% of the time if the person is telling the truth. Pay attention to that part. 10% if the person is telling the truth. And it will also indicate a positive reading 95% of the time if the person's lying. Suppose that a random sample of 5 suspects are subjected to the lie detector test regarding a recent one-person crime. The probability of observing no positive readings if all the suspects plead innocent and they're all telling the truth is. Okay, so the big thing that's going to help you here is to know that they're already telling the truth. So if they're already telling the truth, then we're looking at that first one, a positive reading 10% of the time. Okay? Since they're telling the truth. 10% of the time we're going to get a positive reading. 90% of the time we're going to get a negative reading.
How can we get a 10%? Wait, isn't it 95%?
No. That 95% doesn't apply because they're all telling the truth.
Alright.
Yeah, that 95% is unnecessary.
When it says 10% positive readings, does that mean that
But they're lying. That
it's-
shows they're
the
lying.
machine is correct, or does it just mean they're lying?
That just means the machine says you're lying.
Oh,
even if they're-
positive means lying. Oh, it's error.
Yeah, it's exactly, it's an error. 10% of the time it's making a mistake. Okay, so what's the probability of observing no positive readings? Okay, so what's the probability of a negative reading? 0.9. Right? How many of them are we getting? 5 of them.
0.9, which is a 0.9 from the 90.
So that's what, 59% of the time you're going to get no positive readings. That's kind of scary.
That is scary.
You would want that number to be closer to 100%, right?
Yep. I feel like I would feel like even if I was telling the truth.
Yeah. I don't know.
I really feel like Sharon would.
I'm not here about
Sharon, I really feel like you would.
For sure I would. Even if I was telling you that.
It sounds like something that would happen.
Yeah. No, for sure.
Something that would happen in the life of Sharon.
Or maybe I'm just an amazing lion, you guys don't know it.
Oh, okay.
You guys don't know if I'm lying all the time. Yeah.
Okay, wait, I'm confused.
Sure.
Okay, I get that we did multiply it 5 times because there's 5 subjects.
Fifth power, not actually multiplied 5 times, but continue.
Okay. But the reason why we did 0.9 is because they are telling the truth.
Yes.
So if they were lying, then it would be 0.1. What if it was like 4?
No. If they were lying, it would be the
0.1.
0.05.
0.0.
Because it's 95.
Oh.
The lie detector changes its probability depending on whether you're telling the truth or not.
Oh, okay. So when would we use the point? Okay, the 0.1 is that.
Yeah,
I understand.
kind of. It's a weird question.
I get it because the 0.1 is only there that's because it's deducting from the 0.9.
Yes.
Or from the 100 that makes
Yeah.
it the 0.9. Okay.
Exactly. All right, so we have this number 10. You're going to buy a lottery ticket from the provincial lottery. The probability that you're going to win a prize is 11%, which is pretty good, actually. If you buy one ticket every month for 5 months, what's the probability that you win at least one prize? There's that phrase again, right? At least one.
That means the complement of 9.
Yeah, Sharon. Okay.
It rhymes.
That means the complement of none,
It's gonna be on the recording.
You don't understand. I'll put
says
your
Sharon.
phone
You're
on.
always on the recording.
I know, how can I-
Every one that we do. That means a complement of none. Okay, so what's the probability of not winning a prize, right?
88, 89.
A prize 5 times. 5 times, that's the key, right? And that's going to be 0.89 for the first one, 0.89 for the second one, 0.89 for the third one,
Where are you getting 0.89? Because the 0.11 is.
yeah, 0.89 for the fourth one, 0.89 for the fifth one. That's the probability of not winning a prize 5 times.
Do you care if we just write 0.89 fifth power?
Not at all. You can do that, absolutely.
Thank you, because I'm lazy.
I'm only doing this because the calculator or the computer doesn't know powers.
Oh, okay.
Therefore, the probability of winning at least one one minus the probability of not winning a prize, which equals 1 minus which equals 44, right? 44% chance you're not going to win a thing.
Do you want us to write it like a percent or a decimal?
Decimal.
How would
You
you
want us to round?
No, 4 decimal. Okay, let me get this. Let me get it right. 4 decimal places, rounded.
I like that it's only for shy.
How would you do this if it said like what at least twice?
That's a more difficult question. You have to get to all the outcomes. That's actually going to be the next chapter.
Okay.
Okay, please write.
actually
Keep the receipt.
I'm not gonna disturb you. I'm going. I'm straight.
How about okay, real quick talk, that means tomorrow in class we are working on, well, for period 1 we have 14, 15, and 16, right?
Yeah.
And then for period 4 we just have 15 and 16, right? We did part of it, we didn't finish it.
Thank you very much.
Yeah, so we're done.
Is this gonna be online tonight?
It's going to be online tonight, yeah.
You're gonna send it to us. Are you saying it's already
What time am I leaving? Probably in half an hour. Yeah.